Today I really want to talk to you about the value and improvements that we've obtained by using and really important leveraging the Trimble technologies in real world projects today. So I said I'm Bill Klorman. I'm the president and CEO of Klorman Construction. I'm a fellow of the American Concrete Institute and a recipient of the Roger H. Corbetto Award. Give you a little background about our company before we get going. We were established in 1980. We're a design-build general contractor, and we're one of the largest concrete contractors in California and the U.S. We started using virtual design and construction on all of our projects back in 2010, and in 2005. And so in 2005, that doesn't mean one or two. That was everything that we did as of January 1, 2005 has been modeled. So almost 10 years of actively modeling projects that we've completed. We're recognized as one of the leading VDC companies in North America. In fact, we were fortunate enough in 2011 to be awarded runner-up in Tekla's North American BIM Awards. Our experience is based on all real-world projects. In 2011, we were inducted into Meridian's Hall of Fame in recognition of our best-in-class management. And in 2012, we were awarded the ConstructTech Vision Award Gold Medal for applying technologies to our everyday business. So today we're really going to look at integrating Trimble's databases and how it allows for our workflow that benefits all the stages. In pursuit to us is the sales approach, the estimating of jobs. This is a 3,500 car parking structure in Orange County, California. We'll look a little bit at how we use it in the design phase, whether that's for in-house workflow for rebar or formwork or for structural design elements, and how we use it in construction. In this case, you're looking at one of our transportation projects in Los Angeles. So design, pursuit, design, and construction. We'll start off with the showcase project. This is the Los Angeles International Airport, and what you're looking at is the new Tom Bradley International Terminal. Some statistics on the project. Airport officials are expanding the Bradley by 1 million square feet. It's one of the most ambitious airport projects in the country. The terminal is a 7-story building with more than 665,000 square feet. It has a baggage level footprint of roughly 158,000 square feet. Architectural concrete towers nearly 90 feet tall. 14 new airline gates capable of handling the next super jumbo jets, the Airbus 380 and the Boeing 787 Dreamliner. Walsh Austin Joint Venture is the construction manager. Fentress Architects and John A. Martin are the prime architect and engineer. The project's expected to create at least 4,000 construction-related jobs during its 4-year project schedule. And I can tell you, I've been on site, and there's been over 900 craftsmen on site daily. And Klorman, among other things, is the prime structural concrete contractor and one of the project BIM leaders. So let's look at how we put Trimble technologies into practice. And I think this is a very important shot that you're seeing. It's not that this is a picture of a team on the site that might be what your companies will look like in the future. This is actually what trailers and field offices are looking like today. This is actually our LAX team. You're looking at a couple project engineers, a project manager, and a QC manager, and they're all huddled around this QC manager's desk looking at Tekla BIM site, where they have a confederated model with the structural steel and the concrete model merged in, and they're looking at some conflicts and some issues of how we're going to move forward through a certain phase of the project. But this is what's happening today and where the world has come and is going to. So let's start off in the pursuit of the bidding phase of the project. When we found out about the project, we made a conscious decision that we're going to go after the project. There was 8 other bidders for the concrete scope, and everybody was pre-qualified. So the good news for us is that the competition was very capable of doing the project. The bad news for us is that the competition was very capable of doing the project, and it meant for us to be successful in a competitive bid process, we really needed to understand the building from the very get-go and look at all the opportunities we could find with our collective experience to take advantage and be the low bid on this project. So as you zoom in on this initial model, you can see that we've got the existing Bradley modeled in, but we're looking at, in this screenshot, logistics capabilities, where cranes are going to set, what relationships we have to existing structures, where we are on the runway, how close planes will eventually be crossing or nearing the construction activities, and it gave us the ability to really start thinking about what we're going to do. Another advantage because of the Tekla model is that we build on it and it increases the intelligence. Now these gates and these towers are architectural elements. So for us to really understand what's going on, we just increase the intelligence of the model. You can see here we know all of the reveals or rustification strips to within a 64th of an inch. You can see our through-bolt tie layouts are already in. Our transfer of our panel layout is shown on the model. And here's something that you don't see very often, but we do as a standard. All of our formwork to build these buildings are added into our model. So the intelligence of the model gets greater and greater and greater. Now, it's not just the fact that we have this geometry or this representation of what we're looking at, but we're able to extract this information. So because, for example, in our formwork, we've modeled it into the building, we now, at the bidding phase, it can extract exactly what it's going to take, not only just a representation or part marks, but you can see here we actually have the bill of materials of what it's going to take at bid time to know exactly what our costs are going to be, what our productivity rates can be. It also gives us the ability to check our inventory to see if that's something we're going to be able to provide out of our yard, if it's something we're going to be able need to rent, if it's something that we're going to use as an incentive to get the project. But again, all of this information, when you're bidding projects of this size, you don't have months and months to study it. You have a couple weeks to put this project together and not make mistakes. Another nice advantage of our approach with Trimble Technologies is that not only do we have the model in Tekla, but now we go into Vico Office and we're able to bring that model in. You can see here we have the model in the viewport, but we're now going into cost planning, and this is our cost planner module. To some of you, it may look just like an estimate. It actually is an estimate, but we use it for multiple purposes. One of the first things we use it for is for construction caliber takeoffs. This gives us the ability to not only know by gross areas, but it gives us the ability to really understand the building in a location-based management. You don't come out and build the building in one full piece. We know that horizontally we're going to divide the building into casting areas, and vertically we're going to divide the building into areas. So using Vico and the location-based management structure, it allows us to develop our cost plan based on that. It also allows us to look at our various consumption rates, what formulas we want to use for our data quantity or our source quantities. If we're looking at hourly, lineal foot units of measure, we can roll everything up to look at common denominators. Because again, at the bid phase, we're trying to look at all the different attributes and from different angles that somebody on the team is going to spot something and say, wait a minute, looking at that from a lineal foot or looking at that from a cubic yard or looking at that from a man hour, it doesn't make sense. I think we can do better. And of course, that becomes the art of the estimate. It's not so much just the quantity survey, the mechanical approach, but it's that visceral, that gut approach that the team really needs to be able to put together and draw from all of its resources. So another advantage in the Vico process gives us, this is called a flow line or a line of balance schedule. Because we built the model in Tekla, we brought it into Vico Office, we worked in our cost planning, our consumption rates, our man hours are in there. We're now able to look at the project in a very, very unique fashion that lets us look for things. For example, here, inefficiencies. We'd like to see the lines in the schedule as close to vertical as can be done, and stacking. When we see big gaps, we already know that there's got to be some inefficiencies here. Now maybe this crew needs to go faster, maybe these crews are going too fast. Looks like we may have some interruption. When we drill down and look at this a little bit further, we actually find out that this task activity is rebar, and these are formwork lines, and we want it to be the start of formwork, the rebar comes in, and the finishing of formwork. So it works out okay, but it allows us to really analyze what do we want to do to make sure that we can deliver the project predictably and controllably, but that we're not wasting money by letting the job extend too long. We'd incur additional general conditions for no reason. It should make us uncompetitive. So another thing that we brought in from Trimble right away at the bid phase was Prolog Manager. One of the things this project had was a very extensive good faith effort that had to be demonstrated with the bid, that we not only followed the procedures of the good faith, but we actually went out and did at minimum what was required and documented what we did in even a greater fashion. So by using Prolog as our project management tool, we knew that we could not only document it, but we could show our ability for transparency during the bid phase and the ability for us to manage complex projects and tasks and be able to report back on them consistently. So by bringing in Tekla modeling, Vico Office, and Prolog Manager during the bid stage, we were actually able to determine the responsible low bidder, and we were awarded the project. So that was quite a feat for us, especially when you consider the pre-qualified competition that we were up against. So now let's go ahead and move from the bidding phase into the construction phase, or building the project. Because we already started in the bidding phase with all of our technologies being brought in at different levels, we now just jump straight back into Prolog Manager as our project management solution. It's already started to be populated with the project through the bidding phase. And so now you'll see in the navigation plan, like here under document control, we're already starting with closeout. We have ways of tracking conversations, our drawings, hot lists, or what we like to use are constraints. Basically what we use a constraint for is the ability to track items that can limit our forward progress or the project's forward progress, and be able to report those to either who we're contracted to, or subcontractors, or other stakeholders on the project. So we can do that on the fly with a click of the button, and then we've got those constraints. Of course, issues, meeting minutes, and we can go down all of the navigation panes and see this level of detail in every phase of the project. What we tell our people is put everything in Prolog. You need to put everything in because you're going to need it at some point in time during the project. The big challenge is you just don't know when or what exactly you're going to need. And just in some examples, it may be in processing change orders. It may be in analyzing time impacts to the project, whether it's internally or externally. It may be looking at schedule fragnets, why they exist and how do you make sure they're all there. Job cost issues, whether those are internal job cost issues, external job cost issues, disputes that arise on the project, claims that may need to be processed on a project, back charges that inevitably come up, whether it's between our subcontractors or the people we're contracted with, productivity analysis. Are we making our numbers? Are we not making our numbers? Are we making the commitments that we've made to other people on the project? Audits, internal audits, surety audits, banking audits, or contract obligation audits. And then, of course, handover. So by putting everything in Prolog for our project database management, we end up with the ability to have better communication on our projects. We have shorter response time, and we have increased accountability, predictability, and control. And those are huge, huge things that end up ultimately to the bottom line of our company and to the stakeholders on the project. Now, as the project evolved and as technology evolves, one of the nice features with Prolog Manager was the ability to move away from the desktop solution and move to a web-based solution. So what you're looking at here is my personal dashboard. This is Klorman's Converge version of Prolog. And again, you see basically the same navigation panel on the left. Some things have changed. We have better project files that we have dedicated, that we have access for up and download capabilities for all of the team members or stakeholders that are given different security access. Of course, cost control and document control and field administration, but a very nice new issue that came in with Converge was the ability to have cash flow availability to all of the our project team that are involved at that level. And it's not just cash flow of being able to look at a revenue side per contract or per vendor, but having the ability to do what we call FACs, forecast at completion. And you know, that's huge. You look at your job cost reports, you need to be able on a timely fashion know where you are on a project. And so this gave us a nice internet-based solution to be able to really pick that information up on a daily basis and monitor the project. You see other things that are key KPIs or key performance indicators for me. One of the things we look at is safety. You can see at this point of the project with 901 days, we've already had 243,000 self-performed man-hours on the job. We've got 16,000 man-hours of subs that are in direct privity of contract with us. We can see what safety notices top our list and what's happened. We have some graphs and statistical things with regards to potential change orders on the projects. I can see here right away in our prime contract, we've already had 273 prime contract change orders on this job. You'll notice another interesting statistic over here in the time. The project originally was expected to be about a 13-month project. You can see here that we're 129 weeks into the project, 179% elapsed time. That starts supporting why we have so many change orders. In fact, I think we have north of 900 potential change orders submitted on the project. But great dashboard for me to be able to go in and look at what's going on in the project. And then, of course, I can drill down on everything. Not only were we able to take advantage of internet-based solutions from a tablet or a computer, but now we were able to come in and look at an iPad solution. What you're looking at here is one of our superintendent's tablet or iPads, and I think this is a second generation. And you can see what we have here is all the various checklists, daily details, work journals, events, the different group headings that they can drill into while they're on the site. Now, what's so important to this, to our company, is this allows us to break the hold of an island. We look at the corporate office or the field office or a trailer as an island. And the problem with islands is when people are in an island, they're detached, right? Obviously, they don't see what's going on in the job. They don't have the ability to understand things in real time, current. They've got to wait for things to pop up or be reported to them. So by fitting our superintendents and PEs and project managers with the iPad solution, they can now we've statistically have proven that we keep people out about 35% more time on the job site than they would have been without that. And that's just about 3 hours more of their day is now spent walking the job, being involved in decisions real time, as opposed to being stuck in an island and detached from the action. Another great thing is by being on the job site, they hear things, conversations that may not be important at the moment, but are registering in their subconscious, and something comes up later on, they know what they're talking about. So moving a little bit farther forward, not only can we look at this in a list view, which you're looking at here, but we can go ahead and look at it in a plan view. Now this is very powerful as you're walking through the job to be able to look at something that's happened, find it on the job site, on the plan, and understand what it is that took place, where it was, and this information works both ways. You know, it uploads and anybody else can see it. It's not limited to just one user. Another advantage, because we started off with Vico Office early in the process, we're able to take a look at cost planning and cost explorers, look at trends. We can compare various versions of our estimates. In this scene, what you're looking at, you're getting to see two things. one of the issues is all of these red indicators are saying that there's been changes in the budget. Well, a few minutes ago I just showed you that we have over 273 approved change orders on the job, and the job's been running for, instead of a year, 3 years. So you would expect to see that there's changes, and that's why there's so many of them on this. But we can now go into the cost planner. We can look at variances. We're able to look at productivity rates, where things have changed, where we thought maybe we could do something at, say, a 0.013 consumption rate, and they actually ended up changing to a greater rate. We have all of that information to be able to go back, not only analyze where we've come from, but where we're going to and what impacts that's going to have in the project towards completion. Another very important tool and leveraging integration between dissimilar databases. What you're looking at here is the Tekla model in the background, and here you're looking at our workflow manager that takes information from the BIM and imports it directly into our project management software. Here we're dealing with RFIs, and this particular RFI 151, what we've been able to establish is when we make a change in the model, and I guess I should back up a bit and tell you that we use the model as our central repository. Everything that happens in the project is recorded in the model, whether it's a bulletin, an RFI. We have hyperlinks to specifications, to PDF files that have photographs, that have statistical information, mixed designs, testing reports, all of the data, repairs, anything that's happened, surface finishes, all of that information is captured in our model. And then from the model, we're able to trigger notifications to the different software platforms that we're running on the project. So in this case, a VDC engineer has gone in, made a change in the model. He's created an RFI for verification. It's linked and connected to our project management solution. And now a greater action happens. Not only is it recorded and captured, but an automatic potential change order is created, a notice of change is automatically created, and an email blast is sent out to the project team members, whether you're an engineer, a superintendent, a project manager, a QC manager, an executive on the project. Everybody is now aware that this has happened. So there's no secrets, there's no things that get dropped where the ball, nobody told somebody about it. And as we go through our different disciplines, if you're an engineer and you have certain tasks you're doing, or you're a project manager, when you go to your open RFIs or you go to a meeting, all of this is here so that whatever your discipline is on the team, you can do your work. And so what we've done is we've taken out a number of steps for people doing repetitive work, and we've been able to integrate the databases so you do it once and everybody involved gets the benefit of it. Other examples of advantages of having integrated information and being able to grab that information on the fly. This is an actual exhibit. There was some change orders on the job that dealt with time for basement wall construction. And so literally in 3 minutes we were able to produce this document. What you're looking at is a plan view of the core. These are the basement walls. And every colored segment you're looking at is approximately a 60-foot, section of the basement wall. And you see the various areas, and you see a lot of little things around that. What those are, if we zoom in, those are actually every single RFI that affected each individual section of the wall. And we're able to track this. So if you can imagine being in our position, there's a question about an impact related to RFIs, and we don't really think that the extension of time that you're looking for is meritorious. We can literally hit a button, extract this drawing, walk into a meeting in 5 minutes and say, here's exactly where this impact. And if we just back up for a second, now all of a sudden this drawing has a lot of meaning. When you look around, with the exception of one 60-foot wall, which ultimately did have a change, an RFI, you can see the magnitude of clarifications and RFIs and changes in the work that affected all of this area. So a huge change management tool, a huge communication capability, and again, real time, on the fly, being able to know where you are and what's happening on the project. Look at some more construction technology that we used on the project. What you're looking at here is Trimble's Nomad. This is an LM80 handheld computer, and this is what talks to our robotic total station for all of our layout and tolerance control. Now, I don't know if a lot of you have ever seen this in action or not, so I'll show you a little bit about it. As technologies advance, we just recently were able to purchase a newer technology that does very similar things but does more, called a Field Link. It's now more of a tablet size computer and has better resolution. It's 3D. It gives us the ability through what's known as Trimble Vision to actually see the photograph of what the robotic total station is looking at in real time with an overlay of the control and layout. But let me show you how this works. So what you're looking at now is a layout carpenter who's talking to that robotic station. You can see the robotic station waving to us. And what we do is, using our Tekla model, we create our control points or our layout points of what needs to be laid out on the job. That information is then transferred to this LM80. Now, another thing you should be aware of for efficiency, this LM80 has the ability to have Wi-Fi. So we've set up the Nomad with an email account. So when a change comes in on the documents and the engineer updates the model, on the fly, in real time, that updated layout is emailed to this handheld instrument, updated, and the field is as up-to-date as anybody else in the whole project. Now that's a huge real-time benefit. Another big advantage of going to robotic stations is that the reduction in labor cost and time. What we used to do this layout with 2 to 4 people, we're now able to do with 1 to 2 people. Literally cut our cost of layout in half, 50% reduction in cost. And on a typical project, if you think that layout for our organization usually runs in the area of about $175,000 to $250,000, you've now looked at cutting that by about $100,000. That's a very big dollar to either use in your advantage to be competitive or to use to your advantage to increase your margin on a project. So unfortunately, you're not seeing this. This was supposed to be a screenshot of the layout of what you saw on that. Another great advantage of what we're able to do is do what's called direct reads. And I think this is one of the most important advantages to increase the quality of buildings and reduce unnecessary expenses. What I'm going to show you here is the ability to as-built the structure. What you see here is a field engineer with the prism that's connected to the robotic total station. And he's set up, we just poured that foundation yesterday. He's setting up over this large embed that has to be right on the money. And he's going to shoot the coordinates of that anchor bolt so that we know exactly where that is in XYZ coordinates. And as soon as he plumbs up over this, he's going to hit send. And that information has now gone directly back to the model. So now what we're able to do is take a look at that information in real time of what problems we have. Now what you're looking at, he was shooting this base plate. The yellow spheres are the actual layout that we did for initial control. The orange spheres, we've actually elevated them for clarity in this picture, but those are the as-built readings. Now what that's given us the ability to do is instantly produce a tolerance report. Now this fit-up tolerance report is extremely important because not only do we know where it is, we know what the design tolerance were per our contract obligations before and after pours, what they were, and if we're okay or if we're not okay. Okay is great, but what's more important to our organization is the not okays. If you look at how much money is spent and how much delay is added to projects because of fit-up problems where a follow-up trade doesn't find out about a problem on the job until it's out there doing the work. From a corporate standpoint, we used to carry about a $500,000 budget annually for fit-up problems, for errors and tolerance that weren't accounted for or corrected. Today, because of this technology advancement, we carry about $80,000 annually for it. So a huge savings in our cost of doing business. The other thing is that these change orders, in this case, the structural steel, he normally wouldn't find this out until a couple months down the road. He comes out, his survey crew shoots, says, oh, you have a problem. We've already manufactured our base plates. They're already welded to the vertical elements. It's going to cost you $10,000 a location to cut these off, re-weld them. We need an RFI to do it. We need to go back and maybe we oversize the bolts and use plug fills. Maybe we cut the plates off. Whatever the solution is, but it's time and it's expensive. Now, 24 hours after we poured the concrete, we're able to go back, either see if we can fix it internally. Do we need to chip and remove it? Can we hickey it? Can we augment it in some fashion? Has the follow-on trade already started? If not, we can go to their shop or email them the tolerance information, work with them collectively to figure out a way to resolve it. All of these things are proactive instead of being reactive. And again, it's all because of the ability to take the technology that we're employing on these projects, integrating the various databases, and reap the real-time advantages of that. Staying with tolerance control and everything, this is actually one of those 90-plus foot tall architectural walls that we looked at the beginning of the presentation in the bid phase. And what you're looking at here are all of the embeds for the welded connections or bolted connections for the structural steel frame to attach to this, at this point in time, freestanding 100-foot tall wall. Now, not only are we able to use this for layout of our embeds when we're constructing the wall, but again, from a tolerance report, after the lifts are done, we go out and shoot those, and we know exactly where each embed or each bolt or each ledger item is in place, and if we have a problem or if we don't have a problem. And we can catch that at each pour. We don't have to wait until the entire wall is done. Same thing we were able to do for all the structural steel floors. We've got the before pour survey. We have the after pour survey, so we know what deflections have happened. We know what the tolerance controls. We know our quality of our floors. In addition to doing f-stops, we have the ability to go back and really understand the performance of the building as it's loaded and as work comes on. It's retrievable. It's interoperable. We can use this in a model view. We can use this in a plan view. We can use this in tolerance reports. Another technology that we used on this project was 3D laser scanning that we merged with our BIM model. What you're looking at here was actually an archive file. During construction, we try and scan the project. And a couple months after this scan was taken, a question came up about tolerance of this particular basement wall. Now, the tolerance issue wasn't a surface issue. It was a vertical alignment and a tilting issue and a line or plane issue. Well, we were able to vet out by measuring it in the model that we were well within tolerance at the time it was casted. But what was interesting to us during the review is what you're looking at here in gray is the actual as-built condition moving through the model. So we were able to see, hey, there was a surface blemish. We went back out and checked it. It was well within our tolerances. In fact, this turned out to be about a 32nd of an inch thick bulge in the wall. But again, we knew about it because of the technology. Had there been an issue, we wouldn't have been able to address it now rather than later in the finished trades, which would have been very costly and time-consuming. But another very important thing happened that we were able to capture from the laser scanning, and that was during the course of the project, in the foundation phases, the owner had directed the structural steel contractor to go past the concrete work. So in this case, they erected all of this structural steel that you're seeing, but we had this multi-story shear wall that needed to get in to tie all of this steel together and get the diaphragm back in. Well, by taking the 3D laser scan and moving that into our BIM model, we were able to find out a very interesting truth that the structural steel was actually in the wrong spot by about 2 inches, which meant that the wall was going to engage differently into the connection than was anticipated. But because we captured this early in the project, we were able to save a very large change order. We had a smaller change order that dealt with how to deal with that, but we were able from this information to go back to our project database or our project management solution, create an RFI, capture the scanned information, let the design professionals and the owner and the construction manager understand what was involved here. Foundations had already been poured, so we had some limitations, but we were able to collectively work together on a solution of how best to resolve this at the least interruption to time and cost. Staying with taking advantage and moving that technology along, I want to show you how we were able to take the information from the model, which we consider our models anatomically correct. That means they're built to the exact tolerances that we expect to build the building at. Because of that degree of accuracy, we're able to extract all of our information, our formwork information, our rebar fabrication and erection information, and I want to show you a little of that right now. This is one of the cores. This is the south core, and you can, what you're looking at right now is a first or a second lift of the core. But I want you to see how every piece of rebar is drawn exact. You can see our right angle bars are in. You can see our add bars. You can see our exact lap splice that's in. You can see how these bars are going to develop past the openings, our larger bars, our jam bar conditions. If we look at it from a higher view, you can see exactly where the bars are going to dogleg. You can see our graduated ties. Now this is exactly to the piece design and fabrication information. This isn't a hypothetical. This isn't a representation. This is exactly per the piece what it's going to take to build this building. Our individual U-ties. Again, add bars, lap splices, congestion issues, everything that it's going to take for us to be able to do this building. Because it's in the model, we can control our releases. How many pieces, what pieces, if it's been released, if it hasn't been released to the shop for fabrication, if it's gone to submittal for shop drawings. But every single piece is known and understood in the model. Then it's extracted. Here you're looking at our release number 20 on this project. We know exactly what the quantities are, the grades of steel, the lengths, the bend types, what the lengths of those separate bends are, if there's any special understanding of the bend types that we need the fabrication yard to understand. Our placing drawings, our shop drawings are pulled directly from that. Now one of the nice things, not only the level of quality and detail that we have in these fabrication drawings and shop drawings, but should anything change in the model, these drawings are immediately changed. So everything's at real time, everything's up to date constantly. And again, we produce all of our placing drawings and our shop drawings for review. Then we round trip again, going to Converge through our web-based solution. We create our drawings. We merge those into the project record that we're going to have. And we also are able now to create our submittal package because that release drawing now exists in our drawing list. We can go ahead and create the submittal on the fly from a unique package, go ahead and send it in for submittal and approval. Now once the process is completed and the shop drawings have been approved, we now just send that information to our fab shop and you can see all the fabrication that takes place. Ultimately that stock is delivered to the job site, installed, and again, not only do we have the advantages of taking the model and cutting down on our internal workflow process. I mean, that's a big thing that people tend to overlook is the advantages of internal workflows. Instead of having multiple draftsmen doing things with AutoCAD or with paper and having to rechange those layers and discontinuous or lack of continuity between other parts of the operation, all of this is integrated so our internal workflow is cheaper and more predictable and controllable, and our field has produced better. We found that our savings in the field will run from 3 to 7 to 10% reduction in cost because of the productivity. You noticed in the shop drawings that I was showing you in that modeling, we don't just model it by a book. We model it the way our field crews are going to install it. So if our crews would rather have dogleg bars instead of right angles, that's how it's been designed. So we look at the most optimum efficiency of the installation approach when we're modeling this steel so that when it gets out to the field, it's at its most optimum field installation. Same thing with our formwork drawings. I'm not going to take the time to show you all the different formwork drawings, but I showed you early one. Same thing. We're able to part mark and package all of our fabrication drawings for all of our formwork. It's fabricated in our Fontana facilities, trucked to the job in packages, and now we've saved the time of people trying to think and do layout on the field, where now they're assembling an erector set. Part A goes to part B, and they're able to do what they do best, build things rather than trying to take the time to figure out how false work should be designed. Other advantages of being able to use this technology happened, and this is an example that was worth hundreds of thousands of dollars on the project. What you're looking at right now is a relationship between a large structural steel column, which is about 2 feet wide, that had to fit inside a rebar pilaster. Now, at first discussion of it, you don't think it's really a big deal. But in this case, the wall was 30 feet tall, and that structural steel column was designed to fit at the top of the wall. Now, a bulletin change came out, a document change came out. Going through the document changes, we were at the point of fabricating steel and getting closer to be able to pour these foundations. Had we not modeled this, we wouldn't have known, for example, that the lap dowels coming out of the foundation wouldn't work because this base plate was going to be in the way of them. We were going to have interferences with the layout of the Nelson studs with the ties below the top of concrete in the foundation. Not only did we have these type of problems that were visualized, now we had a problem at the top of these basement walls because, the horizontal steel that needed to come into the project would have interrupted all of these ties, would have affected how these right angle hooks were designed to go through the building to tie into other elements. So all of a sudden we had this huge amount of elements that didn't work together. And under normal construction practices or procedures that are followed today, through the time frame of creating RFIs, if this even would have been seen, all of these cages would have been on the job, the foundations would have been poured, we would have had to go back and argue with other people on the job who was going to pay to rebuild these cages, the crane time, the crew time, the stand around time, all of that, and then the cutting and manipulation. It just would have been a mess. This happened, I think, 80 times on the project. So again, by modeling it, by looking at updating the model in real time and confederating our models with other discipline work, we were able to save a huge amount of money and time on the project. Again, confederating the model gives you other aspects depending on what your deliverables are. In this case, we're looking at a number of concrete elements, but when we confederated it with the MEP, the HVAC system, and the electrical and mechanical trades, we found out that this shear wall, you can see our reinforcement in there, had no penetrations for all of this massive ventilation to get through this wall. Well, because we caught this early on in the project, we were able to take advantage of that, modify our formwork, create a dialogue with everybody involved in the project, and take advantage of it early in the process. Under normal circumstances, we would have, somebody would have ran out before we closed up the wall and said, wait a minute, there's no hole in this wall. We would have had to take down forms, take down rebar, remodify this, and then go back to delay and argue who's going to pay for this. Other advantages from confederating the model, you get to look at lots of things that you wouldn't normally be thinking about. On this particular project, the engineer of record had very, very demanding specifications for construction joints and penetration. So he has a lot of boundary steel. What we noticed here is there's actually a construction joint right here where all of this conduit, this data and electrical supplies are going through the wall. Had we not found this out early in the project, these walls would have been up, the jam conditions would have been in place, and we wouldn't have been able to fit any of this penetration through there. The owner got other advantages. You can see the MEP conflict here with coming through at an elevation problem. Here was that wall we were just looking at earlier where there was no penetration through. So lots of things come depending on what your trade is and what your expertise is. Just from looking at this visualization, whatever your position on the job, you're going to see things that other people aren't going to see. Let me show you another advantage of what we were able to do on the job, and this is integrated program validations. We use this for lots of things, for safety, for constructability, for vetting that our construction sequence is doable, that our time frames work. We had a couple of situations on the job where we had to do presentations similar to this to ownership to show how things work. I showed you earlier that RFI located in the walls around the basement. We actually did that in a 4D simulation and showed the walls flying in based on the time frame. But let me show you this. This is a good example of 4D validations or simulations, and what you're looking at here initially is a big picture. You've got the environment around the project. You can see the different towers under construction. You can see that it's tied to a duration of days and weeks, so you can vet out the different things that are happening on the project. And that's great for orientation, coordination, and general verifications. But what's really important, besides just seeing this thing, is being able to go in and validate very specific activities. Here, what we're going to show you is a specific formwork that we developed, a climbing form system for this particular core. And we had to be able to prove that everything was understood and being able to cycle this in a week. So you can see here the column forms are flying into the process. The columns are poured. And now once we go ahead and strip these forms, we go ahead and start the casting cycle. Now, there's a lot of things to validate that this cycle could be done in a week. The first thing is the movement of these flying tables. Now, on this particular project, we couldn't fly from two sides, so every table had to be moved from only two sides with the crane. So we're able to validate and vet out not only the sequence, but crane capacity, reach, how things were going to move, the sequence of movement. We're able to look at how the safety rails would move with these forms, how they would transfer underneath to be picked and rolled out. You'll notice that the plywood is short of the edges. That's because it's anatomically correct. You notice that we have these areas left out. We couldn't move these deck tables around these columns if they were full pieces. So if you're a formwork carpenter or a GF or a superintendent or a QC person, you see, okay, they understand that they need to come back and do these infills, and they've left, the forms are designed to take that infill process. So as we spin through the model a little bit farther, you'll see that as the tables are finishing up, the handset crews are going to start coming in, and they're going to start filling in and buttoning up these decks. As they're buttoning up, the table crew is now moved down to take the reshores, and they're moving all of these reshores up through the building ready to pour concrete. We pour the slab monolithically with the core walls, and we've now validated that all of the activities and components necessary to complete that task in the time frame we're anticipating is doable, and we haven't overlooked anything. And of course, because it's in the model, again, we have the ability to extract the formwork drawings for that, the consumption and productivity rates, the bill of materials, everything that we need for our work sequences, our utilization, safety, and orientation. So 4D programming validations, again, because of having the model, having Vico, having our project management solution in here, having our tolerance information, all of that stuff works together to produce that integration. Let's go ahead and look at some of the returns on investment. Because of the technology that we use, Trimble technology, we consider it an accelerator. And what I mean by that is the technology doesn't do our job for us, but it allows us to accelerate what we do best in building and analyzing and studying a project and being able to take, the vast amounts of knowledge that we have throughout, our field crews, whether you're a laborer, a carpenter, a general foreman, an iron worker, a cement mason, a pipe fitter, a superintendent, quality control people, testing people, all of that collective information, and accelerate that through this technology. And because of Trimble specifically on the LAX project, it resulted in Klorman being awarded a truly landmark project. It resulted in Klorman being able to manage and construct a landmark project to a successful and very important profitable completion. And it increased our ability to win more projects. Not only did we win this project, but because of the gains and strides we've made on the LAX project and our technology, we've been able to implement this on many more projects since this project first started over 3 years ago. We can drill down a little bit more granular and give you some more very specific returns on investment that might help you in considering advantages of looking into other solutions for your organizations. Looking at Prolog specifically, Prolog has reduced our average management cost on a project by over 8,000 man-hours per year on a project. That's about 160 man-hours a month, or basically, taking off 4 people off of a project where we would have to do all these things manually or using technology that isn't integrated. Prolog's enhanced our change management. You've seen some of the examples of being able to create information from the database of RFIs to support things that happen, having great documentation at the push of a button. It's allowed our management and supervision to spend 35% more time in the field, so we have better execution of the work, better understanding of the work, better real-time communication between the field and the office. And it's created real-time information exchange between our field and our field office and corporate office. That clearly has given us, from an executive level, much faster decision-making with much better information. I'm sure many of you have experienced the frustration of being on a job site, knowing you need a decision made, knowing that it was at a dollar level, that it had to come from somebody above the job site, and having to wait for no good reason other than the failure of the ability to transfer information at a real-time pace. Excuse me. Looking at Tekla, some of the advantages that we reaped from Tekla's technology: increased offsite prefabrication by 30% from what we used to do. We increased our field production because of better constructability by an average of 7%. We enhanced our change management, being able to support the change management process with before and as-built and as-of-time documentation and representations. And don't underestimate, 3D representations are huge to be able to show somebody. A lot of people start saying all it is a pretty picture. Well, that's the least of what it is, but that pretty picture is still worth 1,000,000 words. It's increased our safety planning. It's reduced cost and streamlining our daily workflows. I showed you shop drawings, fabrication, erection drawings, bills of material, releases. All of that now is integrated and done once and can be updated in real time. It saved our owner what we have attributed to about $350,000 in plan changes with early detection. I showed you that cast-in-place column and steel column problem that was found. The BIMs created a reusable database. Now that's really important, because as the model grows intelligence, it's not just geometry, it's geometric representations that are linked to various information that can be used and leveraged repeatedly for different requirements, whether it's at the end of the job in a handover situation, whether it's during the course of the project for change management, whether it's for coordination purposes, conflict resolution, constructability, understanding, sequencing, logistics. You keep going back to this well, or this repository of information, and you keep increasing its knowledge. Looking again at a granular level with Vico, by creating those construction caliber quantities based on location, it's helped our estimating and our project team do better estimates and reuse. Reuse is a very important thing. As a concrete contractor, we have to be the epitome of process and reuse. Unlike a steel contractor where you can balloon frame things, we have to build things so that the material we use to cast the first pour can be reused for the third pour. The second pour goes to the fourth pour, and on and on. So by being able to increase our reuse through efficiencies that we found in Vico has increased our overall accuracy and performance by 3%. It's reduced our time of estimates by about 8 man-hours per estimate. Now this is a little misleading. I'm specifically talking about every change on this job. When you look at these PCOs on this job, when we have 900 potential change orders on a project, these aren't just change orders where you can throw out a number. There's a large bureaucracy involved. There's a lot of checks and balances that go through, and where the funding, if it's even approvable, how that'll take place. So there's lots and lots of man-hours involved in putting together a presentation. I mean, without making this humorous, we literally have had change orders for $1,500 that have 141 pages of supporting documents. So it's very labor intensive. By using Vico, and we were actually able to reduce about an average of 8 man-hours to what we produce today to what it would have taken us. Produce schedule control that has resulted in projects being delivered consistently 5% faster. And this is an unbelievable and astonishing rate for us. Because of the ability to take that model into Vico and not only do cost planning control, but the ability to take that into a flow line or location-based management structure and understand the modules by their location and really look at reuse and casting cycles, it's given us the ability to really vet out our schedule problems. If we look at some of the other technologies that we've shown you today, robotic total stations clearly has reduced our cost of layout by 50%. It's reduced the cost of our rework and tolerances, not only on this job, but corporate-wide by 80%. It saved the owner nearly $100,000 because of advanced coordination and planning problems that we were able to solve from 3D laser scanning working with the BIM models. It's provided invaluable as-built and as-is at the time documentation. You know, everybody talks about as-built record drawings. There is nothing more powerful than bringing up a 3D, real-world, real-time representation of what the world looked like on that particular day that you can go in and measure and check tolerances and pull quantities from and move that information into a BIM model or extract it for other representation or data collection capabilities. And that is an invaluable amount of information. And of course, it obviously enhanced our change management on the project. So with that, I'd like to really say thank you for taking the time to listen to what I had to say and some of the advantages that we've seen by using Trimble technologies out on the LAX project and all of our projects. And with that, Holly, I guess I'll throw it back to you if anybody has any questions and they're still awake.
Thanks so much, Bill. You know, it's funny, but you always think of Trimble as the iconic yellow layout equipment on a construction site. It's nice to see it's also the different software solutions, you know, like the Tekla, like the Prolog, even Vico. So thanks for showing the audience all of those different applications. Let me go ahead and take control back. Okay. Let me see if it'll let me share my screen. Well, it is time for questions and answers. To ask a question, remember, just locate the questions pane on your GoToWebinar control console. Go ahead and type that in. And we just answer the questions in the order in which they're received. Just a reminder, it's me in Massachusetts, Bill in Los Angeles, and I think I see Clive out in LA as well, so he'll be able to help with any questions. Bill, do you have anyone on your team joining us, or are you flying solo?
Oh, I'm going to fly solo today. Actually, there are a couple team members that are watching this, and if I can't handle the answer, we'll time them in on it.
Perfect. All right, let me open up the questions. See if I can't make them larger on my side. Okay, so Brian asks the question I think half the audience wants to know, and it's, with all of the software and with all of the technology you were using on the project, how did the project get so far behind? What was behind those 900 change orders?
Well, great question, and it didn't get behind. What happened is people have, well, fundamentally what happened is there was changes in the design that took place after the project was awarded and certain concepts were put in place. And part of that has to do, if you think about a terminal really being a giant oversized mall, it's a retail center. So as concessionaires or vendors that are going to take space in the building start realizing that they need different requirements, the airport authority is really forced into a predicament that they need to be able to deliver certain things to these operators. And so that was really the genesis. It wasn't so much that there was bad work or poor design. There was just legitimate business decisions that came up that caused reworking of existing conditions and making sure that the end product would be, the LA Airport World Authority really is delivering a first-class facility. And to do that, they didn't want to miss opportunities that were important. This structure is going to be used for the next 60 years, and it had to be able to have a service life and capability of doing that. So really, it wasn't that there was problems so much as it was modifications that were necessary to make sure the end product was really what was best for the city of Los Angeles.
Okay. So David has a question. He wanted to know what solution you used for electronic contract documents in the field.
Well, I'd almost like to ask David to clarify electronic documents. If you're just talking about how did we deal with converting 2D documents into PDFs or using AutoCAD files and things like that, what we did is in the field we used Tekla BIM site as a way to view the electronic model, and we have BIM site on all the desks. We took advantage of PDF files for looking at other electronic data. And we looked at pretty much everything electronically, and we extracted drawings electronically. We really cut down on the amount of paper that we produced on this project. So the repository starts in the model, but using Converge, because of the ability to upload and download, like a SharePoint almost, we use Converge as a repository for electronic documents, and we use that technology to allow people to push and pull whatever documents they needed, and then they were also able to look at that on their iPads, and on their desktop computers. I'm not sure, David, if that answered your question or not.
Okay, David, if it did or did not, just shoot us another question and we'll get, oh, David says yes. Thanks, David. CT has a question. What was the original schedule and the budget compared to the final outcome?
Well, I can tell you the original schedule was about 13 months, so just over a year, and we will end up being there about 3.5 years. So okay. it pretty much tripled. And our particular scope of work, reasonably tripled also.
Now, Bill, was IPD used for LAX? What was the contract type?
Well, the contract was a standard subcontract contract relationship. Walsh Austin was the construction manager at risk on the project and issued the contract. But IPD wasn't used in its classic form of integrated project delivery, but Walsh did champion a very good BIM program. There was a BIM execution spec in the document that required all participants to model. They used a big room approach where on initially a weekly basis and then tapered off, where all of the disciplines working on site would have their representatives in the big room, and we'd go through conflict resolution with the MEPs and with structure. And then as the structures got vetted, that ended up finalizing with just the MEP trades. So it somewhat of an IPD standpoint, but the contract format was not IPD.
Okay. Here's a question from Jamie. Using laser scanning, What early growing pains did you experience or learn from?
Probably the early growing pains was time and size. You don't realize, because you're collecting millions and millions of bits of data per minute. I mean, every time that laser scan makes one revolution, I think it creates 900,000 dots of information. So when you spin that scan for about 5 minutes to get the resolution quality we wanted, you end up with huge files. And so that was our first early problem, was not so much storing the information, but being able to go back and lace that information together to be able to have an overall 360-degree view. So I think power capacity was early on. Now, that's relative to time, because if you go back 3 years ago to what you could buy then versus what you can buy at a computer store today, speed of processing and storage have become almost free compared to what it was 3 years ago. So the early learning curve was just that time problem, learning about how to set up spheres so that we could register the scans as we moved them. Other than that, it was remarkably easier than we thought it would be on large sites. Of course, we did find that the more undulating surfaces we had, where we need to be able to record multiple sides, we had to move the machine a lot more than we thought. When you first use it, you have this fantasy that you put it in the middle of 40 acres and it'll tell you everything without moving it. That's not quite true.
Okay. So we have questions from our respective states coming up. First, we have John from about 10 miles down the road from us. Hi, John. He asks you, Bill, were you using BIM site for all clash detection? I guess a little clarification. Was Walsh Austin sharing their Revit files, the MEP files, for your use, or were they asking you for your Tekla files for their use? How did you organize sharing all these BIM models?
Really good question. We actually shared. There was a SharePoint exchange where everybody on a regular basis uploaded their most recent files. The contract spec required that everybody provide a Navisworks file. We requested that everybody produced an IFC file. And then if you were using Revit or CAD duct or another file format that was convenient to share size-wise, everybody was uploading that. And so we were downloading. Klorman specifically, we used 2 different solutions for our clash detection. And I should point out that I think clash detection is really the low-hanging fruit. It's a great tool, but so much more comes from it. But we used Navisworks as one engine, and we used Tekla BIM site. Walsh used Navisworks.
Mm-hmm.
I'm sorry, how were you going to say something?
And then for sharing the files, you just used the SharePoint solution.
Well, yeah, sharing was done through SharePoint. And then we, of course, kept our own confederated model where we used IFC files to, if it wasn't a native Tekla file that we would get somebody, we would get an IFC file, which is, a neutral data format that we were able to bring right into Vico and bring right in to Tekla and BIM site.
Okay. So now here's a question from your backyard, Bill. It's from Ralph. He's in Los Angeles. How many of the subcontractors were using Trimble, any sort of technology?
Well, actually a lot. We saw it in different views. Of course, the MEP trades were probably the most prolific with the layout tools, with the robotic total stations, because of the speed and accuracy and the recordability of it. So I think almost without fail, the MEP trades all use robotic total stations for layout. I believe they all used a BIM solution, CAD duct or other BIM authoring platforms for their overall design. I mean, that was a contract requirement for it. I'm not sure some of the smaller trades that were subcontracted to the larger contractors, I think that they had the larger contractor do their modeling for them. But every contractor by requirement was required to model. One interesting thing I thought was in the BIM spec, the only thing that wasn't required to model was rebar and embeds. And to us, that's so important and historically such a focal point of delays that you can see we modeled every bit of rebar, and that was a huge savings for us compared to some of the other work on the site. We were able to avoid delays because of that knowledge.
Okay. Here's a question from David, and Bill, I think it's out of yours and my bailiwick. Maybe if Clive is on the line, he can answer this. You know, when you showed our superintendent using Prolog Mobile, do you happen to know if Prolog Mobile is a separate cost from Prolog, you know, the general desktop or web-based views?
Sure. Yeah, I can take that. Hey guys, great presentation, Bill. Thanks for sharing all of that. The Prolog Mobile is an independent application as well. So if you feel that you have another project management solution that's working for you, but you would like a mobile solution, then you can just purchase that on its own. Obviously, it's a great complement to an existing Prolog user as well. But there is a cost for that. So get in touch, David, and we'll set up something for you guys personally.
Okay. Here's a question from Dan. Bill, how do you staff your projects from a BIM standpoint?
Another great question. BIM standpoint has completely changed our organizational structure. April 1st, about 3 years ago, we completely did away with the classic project engineer. Today, in order to be a project engineer for us, you need to intern at least 6 months in our VDC department, our virtual design and construction department. And we've now centralized all of our engineering through that department. So a VDC engineer does all of the project engineering duties from submittals, shop drawings, modeling, fabrication documents, you know, everything comes through that. So it's completely changed our staff. It's given us the ability to have centralized staffing so that that staff can work on multiple projects rather than being landlocked on an island to just one job. And again, it's reduced the number of people on site because of the ability of connectivity. They can be anywhere. We do send our engineers out a minimum of 1 day a week to the dedicated job that they're tied to, just to make sure that they can help out with BIM site, see things real world of how construction's going together, and take advantage of it. But when they come back to the office, now they can share with 3 or 4 other engineers in that room to help meet deadlines to deliver.
Okay, I thought I saw another question that was related, but it was not. Here's a question from Sean. How did you ensure that your crews in the field were building what was actually modeled?
You know, that's the classic question about how do you get BIM to the field. And the way we were able to do that, the first and foremost way to do that is through the Total Robotic Station and doing as-builts. We take the model to the robotic station for layout, and we control everything that goes in the ground through that model. When we go back in and do direct reads, or before the direct reads, when we lay out all the embeds, end of wall conditions, you know, all of our control is from the model. So we know that their layout is being run by the model. Then we go back and we do the as-builts with the robotic station and put that back into the model to make sure that they're compliant with what the model is. So that's the easy way. Your layout people are already out there doing that stuff anyways, so you know that they're doing. Then there's, you know, all of the shop drawings and fabrication drawings, erection drawings all come directly out of the model. So if they're building it to the documents they're provided, it has to be what's in the model. So those are just some of the fundamental ways. You know, the 3D laser scanning lets us vet that out. And of course, the eyes and ears, the boots on the ground, people that are in the position to manage and run the job, our QC people especially, are using the model on their tablet or their laptop to go out and inspect what we've done before we close up a wall or after we pour. So there's, you know, it's really not hard at all to make sure that that's happening as long as the model is part of your normal workflow.
Mm-hmm. Well, here's a question that Rodolfo started, and I think I've stitched his comments together here. Bill, if you had cash flow constraints on the project, would you recommend Vico? He goes on to say, I saw the workflow in relation to time and location, but I could not see how it would work where cash flow would be the constraint.
I'm not sure. Maybe we can get him to clarify cash flow as the constraint. If you're talking about cash flow, go ahead.
Yeah, first out of the question, I thought, oh, Rodolfo, everyone has cash flow constraints. We're in construction.
I'm just not sure if he's using cash flow as a milestone or if he's talking about using cash flow to make sure that revenues stay pace or outpace the cost of goods sold, or the it's a kind of an earned value analysis, I think, is what he's looking for, and Vico is fantastic for that. Excuse me. The reason Vico works so well for that is not only do you have the time analysis from the cost standpoint that you correctly pointed out, but we can load the model with revenue and milestone information so that we can use cash as a constraint to make sure that we hit milestones for revenue, earned revenue, or revenue billable dates. And we've seen some projects where a lender or the stakeholder or the owner will say that, on such and such date we'll be able to release you $5 million. And so we want to time our cost of goods sold to that $5 million and make sure that we're under-expensed by the time we get there so that we're not constantly out of pocket. So Vico has a number of really good ways to trigger those milestones of revenue with that. They have a very specific, I didn't show it to you, but they have a cash flow graph that'll show your cost versus your revenue. And Clive, I don't know if you want to chime in on that. I think you know that module pretty well.
Well, I think you explained it well. You've got the quantities loaded from the model that drives the cost that's spread over time in the tasks, and it's represented as a cash flow. And as you said, you can put milestone payments or link payments to tasks, and whether it be by location completion or percentage completion, and that would show as an income, and the balance will be shown. And you can put payment delays, 14 days for labor and 30 days for materials and that type of thing, and really understand where you are and where you're expected to be in the in your cash flow over the project life cycle.
If I can just add one more thing to that too, is Prolog also now with version 9.6 gives you a great capability to interface with Vico on that exact same thing. I showed you the navigation bar that shows cash flow. In the forecast at completion module, it allows you to populate both the revenue and the cost side of the schedule, pulling it back from Vico or pushing it out over time, and then you can export that and use that to cross-reference what your true outcome needs to be.
Okay. The next question coming is from David. Do you have your own detailers in-house for Tekla modeling? And what balance of field and software skill is best for that kind of position?
Yes, we do all of our detailing in-house. We have the ability to work with consultants out of house, and I shouldn't say we never do. Occasionally things will come up where there's just a workload problem, but predominantly we do everything in-house. As far as a skill set, if you could paint the perfect picture, and it depends at what level. If you're just talking about detailing, or if you're talking about managing the model, but from a detailing standpoint, obviously the more constructability experience excuse me, somebody has helps, because you want to build your model or detail your model from a real world. You want the footing to go first and you want the column to sit on top of that. We've had great successes. When we first started out, I, believe it or not, did all of our modeling. And then as we grew the department, today one of our biggest recruiting places is from the universities. the kids are learning modeling in school, so they have a little bit of a flavor. They're not afraid of technology, and then it's up to us to really teach them the procedure. We have some pretty good established workflows to do that. But if you were going to have a smaller office, you can do a lot of modeling with one person. If you took an engineer or a project manager that enjoyed or was passionate about technology, they would be an ideal candidate to start doing your modeling. Modeling is really a pretty straightforward approach, and you just keep adding intelligence to it. So, if you're interested in greater detail about that subject, I can tell you more offline.
Okay. Here's a question: did the owner set any BIM guidelines, or was it the Prime and Klorman's initiative?
No, the owner's contract has a requirement for a BIM execution plan. Now, I think that was developed by Walsh. I think the owner wanted it, but Walsh understood how they wanted to expand that, so it became a deliverable in the contract. And then we exceeded the execution plan because of the level of detail that we took our models to.
Here's a question again from John. Bill, your animation of the flying forms and the climbing core formwork was excellent. This sort of prototyping is very powerful. Can you share what tools you used and the approximate staff time required to generate that visualization?
Oh, sure. The tools that were used in that was a Tekla model. We used Vico to create the schedule information. We also did some back checks with some other software on our schedule. Then we used Navisworks to create the visualization. First we ran the visualization in Vico in the 4D simulator to kind of do it in a little bit more choppier, unrendered version. And then we ultimately put it in Navisworks so we could do a more rendered version of it. Staff-wise time, it didn't take that much time. You're looking at about, because the model exists, all that, just the time to put it together, probably, that was kind of a complicated model. I think it took about 12 to 14 man-hours to complete that full simulation. And that's putting everything together, taking the schedule, adding. See, one of the problems in that earlier version that you saw is that we were still in the process of having to take the time information from the schedule and manually put that into the building elements to sequence in Tekla, and then have to go build that schedule again in Navisworks. Now, fast forward a couple of years since that video was done, and we've come up with ways to automate that transition. So that same video that you saw just now, to just capture it today would probably take us about, because the rendering time's slow, probably about 6 to 7 hours.
Here's a question from Clark. He asks, why did you use BIM to solve the rebar steel beam conflict and not the structural engineer? Or did Klorman Construction do that as a backup for a change order request?
Oh no, we did it because we're the only people that care about it. Structural engineer doesn't draw work at that detail. I don't care if they're doing model-based documents or they're doing 2D documents. They're concerned with the general intent and what they need to get in, but even though there's a code section actually that does cite certain responsibilities of a design professional to do large-scale documents, it doesn't deal with the standard congestion problems that you find in day-to-day work. But because we self-perform our own rebar on the job, we know the complications that arise from too much steel in a corner, jam bar conditions, hooks, and because we fabricate from the model, it's just part of our workflow that we have to model it. And so we reap all the benefits. And that's the thing. The more you model, the more benefits you get. If you were just a rebar contractor and you modeled rebar, you'd probably have to model the geometry. For us, because we're the concrete contractor, we modeled the geometry. We already get the information for our formwork. We model the rebar. We get to see problems that the rebar will do to our placing operations, our formwork, and our rebar operations gets the benefits of understanding all that. So No, we did it because A, it's part of our standard operating procedure. B, it's information that there's no other way to get without us doing that modeling. And there are no design professionals that I'm aware of that model at that level of minutia.
As you said, anatomically correct, right?
Yes, correct.
Here's a question. Is there a direct data transfer from Tekla to Prolog for either RFIs or PCO generation? Could you just explain that workflow?
Sure, the workflow is very simple. There's a module called the Workflow Manager that you launch when you're in Tekla, and it looks for the URL that's pointed to your Prolog Manager database. And it has a very deliberate RFI module in there, so it gives you the ability to look which database you want to open. You pick the project, it syncs with the RFI database in the SQL server, and allows you to create the information in the Tekla model and link it directly to. Now, what's even better than just the ability to link it, now when you save that information, if you go in the Tekla model and you right-click on the element and you do an inquiry of the part, it'll show you an MPS, Meridian Project Systems, record information. It'll show you the RFI number, the description, the impact to time, schedule, drawings, everything you put in the Prolog Manager RFI module now resides both in the Tekla model and the Prolog model. So there's a push and pull relationship, and it's already there.
Nice. We'll have to look into that more next time we're playing around in Tekla. Well, that was the last question I saw in the queue, but if anyone else has any questions you'd like to ask Bill, please feel free to shoot them to me or to Bill. You saw our email addresses right there on the screen, so please feel free to reach out to us. We're happy to help in any way we can. Don't forget, though, that after the webinar, there are just several things to do today. Please make sure you take the survey that's delivered as you leave. Your responses will help us calendar our upcoming webinars. And then we ask you to be honest and dive into a technology discussion with your team today. You know, what solutions have you been eyeing to make your firm more competitive in your market? And then don't think you have to do this on your own. We have a VDC services team that can help your team get up to speed. And of course, if you'd like to learn more about any of the solutions featured in this webinar, please don't hesitate to drop me a line or explore the individual products you see on your screen. We're here to help in any way we can with any questions that you have. So that wraps up today's Fridays with Trimble webinar. A big thanks to Mr. Bill Klorman from Klorman Construction. Thank you so much for today's presentation. It was great to see just how many different solutions can be used on one project. So thank you again, everyone, for joining us today. Have a great weekend. Bye-bye.